Hello ladies and gentlemen, welcome again as we draw the SF and BM diagram for a simply supported beam loaded as shown in the figure below. So the figure above is a simply supported beam with two supports, one support at end A, the other support at end B. The simply supported beam is loaded as follows. At point E, the simply supported beam is loaded with a 2 kilonewton point load. At point D, the simply supported beam is supported with a point load of 4 kilonewtons, and at point C, it is loaded with a point load of 2 kilonewtons. So our question for today is draw the shear force and bending moment diagrams for the simply supported beam loaded as shown in this figure above. Now, our very first thing will be to determine the reactions, because in our case here, the beam is simply supported, and in physics, that is Newton's third law of motion, it usually states that for every action, there must be an equal and opposite reaction. So these 3 point loads are action forces, and these 2 reactions or these 2 supports are reaction forces. So we are going to determine the loads acting upwards. So we are going to begin with the reaction at B. So the first thing we are going to do here is reactions calculations. Now, in this case, we have clockwise and anti-clockwise moments. So we are going to have reaction at B times, we are going to take moments at A. So I can write this in this form, taking moments about point A, we are going to have the following reaction calculations. So we are going to have reaction at B times the distance from B all the way to A, since at point A, that's where we are taking our reactions. So we are going to have RB times the distance from B to A is 1, 2, 3, 4 meters. RB times 4 is equals 2 times the distance from C to A, which in this case is 2 times 1, plus 4 times the distance from D to A, which in this case is going to be 4 times 2, plus 2 times the distance from E to A, which in this case will be 2 times 3. This is going to lead us to RB times 4 is equals 2 times 1 is 2, plus 4 times 2, that is 8, plus 2 times 3, which is 6. This is going to be RB times 4 being equal to 16. So to get the value of RB, we are going to divide both sides by 4. So this is going to be by 4, 1, by 4, 4. And therefore, the reaction at B is going to be 4 kilonewtons. Then from there, we determine the reaction at A. And as we know, as we have defined or stated the Newton's third law of motion, for every action there must be an equal and opposite reaction. So this means that the sum of upward forces must be equal to the sum of downward forces. And in this case, the downward forces that we have 2 kilonewtons plus 4 kilonewtons plus another 2 kilonewtons acting at point E. So the reaction at A plus reaction at B, which is 4 kilonewtons, is going to give us 8 kilonewtons. So to get the value of RA, we are going to have RA is equals 8 minus 4, which in this case is 4 kilonewtons. So therefore, we now have the reactions at point A and at point B. So RA is equals 4 kilonewtons and RB is equals 4 kilonewtons as well. Then from there, our next thing will be calculating the shear forces. Shear force calculations. So the next thing is determining the shear forces at each and every point on our beam. Good. So in this case, we are going to have shear force between B and E. So the shear force between point E and B is going to be 4 kilonewtons. From there we go to shear force between E and D. Shear force between point E and D. So this is going to be 4 kilonewton minus these 2 kilonewton that is acting at point E. The reason as to why we are subtracting is because these are two opposite forces. One is positive, the other one is negative. So 4 minus 2, which in this case is going to be 2 kilonewtons. Then from there we go to shear force between point D and point C. Now, the shear force between point E and point D on the right hand side is 2 kilonewtons. So we are going to take that 2 kilonewtons. Then we subtract the 4 kilonewton that is acting at point D. So that is going to be 2 minus 4, which in this case is negative 2 kilonewtons. Then from there, our final shear force calculation is going to be the shear force between point C to point A, which in this case is going to be the shear force between point D and C, which is negative 2 kilonewton, minus the shear force at point, the point rod acting at point C. So in this case we have minus 2, which is going to be minus 4 kilonewtons. So you will observe that the shear force between point C and point A is negative 4 kilonewton, whereas the reaction at point A is 4 kilonewtons. So that means that the sum of upward forces again is equal to the sum of downward forces. Then after calculating all the shear forces, we use those shear forces to draw or to plot the shear force diagram. So in this case, we are going to have a straight line that separates the negative shear forces, which appears down, that is below this line, and the positive shear forces, which will appear above this line. So we have shear force between point B and E, which is 4 kilonewton. So if we approximate 4 kilonewton to be at that point, we are going to have that. Then from there we go to shear force between E and D. Shear force between point D and E, 2 kilonewtons. Approximately at that point, 2 kilonewtons, both at point E and D. So we connect in that form. So we are going to have 4 kilonewtons at point B. We have 4 kilonewtons here. That is the shear force between B and E. Shear force between E and D, we have 2 kilonewtons. So I'm going to write it at this point, 2 kilonewtons. Then from there, we have the shear force between point D and point C, which is negative 2 kilonewtons. Negative shear forces will appear on this, that is below this line. So approximately 2 kilonewton at that point. So we are going to drop this line all the way up to that negative 2 kilonewtons. Shear force between D and C, negative 2 kilonewtons. So that is going to be in that form. So here we have 2 kilonewtons. Then the shear force between point C and A, negative 4 kilonewtons. So since this is 2 kilonewtons, 2 more units downwards to have 4 kilonewtons. That is between C and A, 4 kilonewtons there again. We connect a horizontal line in that form. So here we have 4 kilonewtons, and then we complete our shear force diagram in that form. So as we have said, the shear forces below this line are negative, so we write negative inside this shear force diagram. The shear forces above this line are positive, so we write a positive sign inside this diagram again. Then to make this shear force diagram to be more visible, we are going to shade it in that form so that we can have that outline being an outline of shear force diagrams. Shear force diagram. Shear force diagram, ladies and gentlemen, it is as simple as that. Then down this line we write SFD. So that is a shear force diagram, ladies and gentlemen. The next lesson we are going to determine the bending moment calculations and use those bending moment calculations to plot a bending moment diagram. Thank you again for watching our video. God bless you.